Hello and welcome back to DfM Case Studies. My name is Chris Gamble and I run the Supply Frame Hardware blog. Today we're joined by John Teel of Predictable Designs. Welcome, John. How you doing?
Good. Thanks for having me.
Yeah, well, can you give us a little bit of a background on where you came from and what you're working on these days?
Yeah. I'm an electrical engineer. Most of my career was spent as a microchip designer for Texas Instruments. Then I quit several years ago and started my own company called Predictable Designs. The emphasis on the predictable. I mainly work with entrepreneurs, makers, inventors, and startups to help them develop new electronic products in a predictable fashion. The predictable starts with education. I do a lot of blogging and providing information on all the steps required to develop a new product. Secondly, if I take on a design project, instead of open-ended hourly billing, I provide fixed price quotes. So that just makes the total amount that you have to pay more predictable. And then finally, my signature product is product/service is called the Predictable Hardware Report. And it's a report where it's designed for new products. Basically you have a concept or a proof of concept prototype. And it's a preliminary design review. I select all the components for the electronics. And then the core of the service is I estimate all the costs to develop, scale, and manufacture the product. So it basically just gives entrepreneurs especially those that don't have any experience bringing new products to market, it just gives them visibility into all the cost and all the steps that lie ahead.
Yeah, that's great. And so as a reminder for people that are maybe joining this video just today and they haven't seen, in the past we've been talking about a product called the K-Box. That's done by Thomas Sarlandi, and so that's a device made for the marine market. It's monitoring lots of different sensors on aquatic vehicles like sailboats. And so Thomas is at the point of a prototype, right? So he actually has a prototype. He's trying to get the cost down. He's trying to make it more manufacturable, maybe change some of the form factors, integrate some of the early feedback he's had. Is this where people usually ping you for help, or what are people usually approaching you with?
It really depends. I kind of have a mixture of, I have, technical makers that I work with, probably about half of the people. So those have tended to do, like the K-Box, they'll do, just a proof of concept prototype. But then the other half are, really completely non-technical, at least from a hardware perspective. I have a lot of people that are software engineers,
right? Yes.
So they have experience with software, but not the hardware.
Right.
And then, I have some that are just 100% pure entrepreneurs. They don't have a huge technical background. They just have an idea for a product. So anywhere from just having an idea, a well-defined idea, you need to have, an idea of, what you want your product to do, what technologies that you want the product to have, and such.
So does it become more difficult if people have already started down the path, or is it basically all the same? So if they have that proof of concept, is it like you're kind of retraining or rethinking a lot of things? Or I assume that when you say makers coming to you with an idea, right? What I imagine is a lot of like Arduino type based products they're like, all right, I want to make this a real thing now, and that's a little bit different than maybe otherwise, right?
Yeah, absolutely. Yeah, they're never in a situation where they're ready to manufacture, so they don't have a custom printed circuit board. It's basically Arduino or Raspberry Pi is what they've done. So it doesn't really have an impact on what I do, because I focus on how you make a product manufacturable.
Got it.
So they may have, doing a proof of concept prototype has a lot of advantages. If you have broad questions about whether your product can solve a problem or how people will interact with the product, then a proof of concept prototype can be very valuable. But I have plenty of people that skip that step entirely, which is something I talk about frequently, that most big tech companies developing new products, they don't start with an Arduino.
That's right.
They jump right to doing something that can be manufactured. The downside is
Well,
that
yeah.
tends to cost a lot more, but it speeds up the time to market. So
Well, and I think another thing too is that I always think about most of the time they're not starting from a greenfield product at all. They're starting from some previous generation, or they're starting from another platform that they're modifying, right? So a lot of that technical buildup is already there. It's just then the new part is the part that has to become manufacturable, right? So they're doing an add-on module, or they're switching out the
absolutely.
processor or something like that, right? Because that's especially for the larger companies that are already in full scale production.
Yeah, yeah. Trying to reuse circuits is obviously something any big company is always trying to do. They don't want to have to reinvent every single feature every time
Right.
they design a new product.
Sure. That makes it predictable, like you kind of
Yeah,
focus on.
exactly,
Yeah.
exactly, exactly. So, big companies and entrepreneurs are always striving to make things predictable.
Right, and I think that the people that are coming in from an outside perspective, that are starting from a greenfield, are likely doing it from a maybe borrowing open source hardware, or they're using other people's early circuits. But again, that doesn't necessarily mean it's manufacturable. It could just mean that it's kind of out there. So let's maybe talk about, how do we make a thing manufacturable? Maybe we could take a look at an example report that you have here.
Yeah, absolutely.
Okay, great. So I'm going to control this report, but then you'll be talking me through it here.
Okay, so this is just the cover page. It's the predictable hardware report.
Mm-hmm.
If you want to maybe pull up the production cost, that's sort of the
Sure.
heart of the product.
Great.
So basically, one of the most important things to do when you have a new product is to know how much it's going to cost to manufacture it. If you don't know how much it's going to cost to manufacture it, then you don't really know how much profit you can make. You don't know how much you can sell the product for. Most entrepreneurs, makers, startups, they tend to make the mistake of fully developing the product, getting ready for manufacturing, and then they worry about what it's going to cost to manufacture. That's not the right strategy. You need to really know ahead of time. I mean, any large tech company developing a new product, they don't blindly go through development and just hope they have a product at the end that can be manufactured and sold at a profit. They have a pretty good estimate ahead of time what it's going to cost to develop and to manufacture the product. So that's one of the main core sections of this report, is the landed production cost. And by landed, it means all the costs, not just to manufacture the product, but have it landed in your warehouse.
Got it. Okay, so as we go down here, it does change with retail packaging, final assembly, stuff like that.
Yeah, so it kind of starts off with, at the very top is the enclosure, so it's just sort of a broad term, or a second, I guess, is the enclosure. Most products, obviously, unless it's a DIY type of product, is going to have some type of plastic enclosure. So that's one of the costs that I estimate. Just FYI, this is just a sample report.
Right,
Obviously, all the reports.
Where can I get a 5-inch color TFT LCD for $2?
Yeah, exactly.
I want to know your supplier there.
Yeah, all the costs are exactly the same.
Right, right.
Yeah, this is just a sample report. Obviously,
Right.
I can't share reports that I've done for
No,
clients.
that's understandable. And actually, if people are interested, I actually did a little bit of this kind of stuff. I did this using Fine Chips Pro, which is actually a supply frame product. I did this in the second video in the series, where I just did it by myself and went through and took Thomas' BOM and did this. So this is actually really in line with what we're talking about. The question I have kind of to start with is that this doesn't, so this is showing the piece cost, but what about tooling cost? Is that somewhere else?
Well, yeah, that's somewhere else.
Okay.
So basically, I break cost into three things: development cost, which I think is pretty explanatory, and then scaling cost, which I consider all the cost to go from prototype to full manufacturing.
Got it.
So the cost of the molds is obviously huge cost, but that's under a different tab in the spreadsheet. So this is just the cost once you have manufacturing set up, you have all your molds, you have all the tooling, and you're just running product. So this is basically just this is your cost of goods sold. So this is the calculation you'll use to calculate what your profit is.
Gotcha. And this actually includes a lot more than we talked about in that first one, mostly because we didn't actually go to the end of it, talking about retail packaging, testing, final product assembly. Like, we talked about assembly, I suppose, because we also went through with Macrofab in the last video. They were doing a lot of the assembly, so we talked about those costs as well. But things like testing and scrap rate and returns, none of that stuff was actually covered. We did some freight, but not the final freight to the customer. That's what I assume you're talking about here.
Yeah, that's the freight from, and that's mostly assuming that once you're set up and manufacturing in Asia. So that includes, them loading the product on the boat, because you're going to almost always ship products from Asia on a cargo container and
Right.
not by air. So it's the cost to get it on the boat, and then it gets to the U.S. or your country, and then you have to truck it from there to your warehouse. So that's what's included in the
I see.
freight.
Okay, so that is kind of the cost that we talked about from Macrofab shipping to Toma. But I thought you were talking about then the. Do you include the shipping costs to the customer or no, or is that something else?
Um, no, typically not. It
Okay.
sort of depends on. In this case, I don't. This is just it could be used for either. This is the cost to get it to your warehouse, but if you happen to sell to a really large customer, you probably won't go through your warehouse. It would just come off the cargo container and then go directly to the customer.
Oh, okay, like a drop
So
ship.
in
Yeah.
that case, the cost should be comparable.
Gotcha.
Smaller customers, you'll typically sell through your stock that you have in your warehouse.
Got
So
it. Got it.
so then that cost I don't include.
Okay, and this one we should mention too. This is truly a scaling kind of exercise too, right? This is listing at 100,000 units, which is most products probably won't get to, right? I mean, but you're kind of just extending it out to show where you could go with it, right?
Yeah, exactly. Just to show you, what's possible once, if you make it to the 10,000 mark, you're doing really well.
Yeah,
That's
I agree.
great.
Yes.
And eventually, hopefully the goal is to make it to 100,000. So that's to just, obviously you're talking, most likely, millions of dollars in inventory to get up to the
Right, right,
100,000
right.
unit.
There's a couple steps in between there, right? Like
Yeah,
maybe
absolutely.
talking to a financier or two.
Yeah, yeah, you're going to need some capital at that point, or a manufacturing partner. You
Right.
don't,
Yep.
if you're lucky, you can find I had introduced my own hardware product to the market, and I was fortunate enough that I found a manufacturer that liked my product enough that they
Hmm.
paid for all my molds,
Oh wow.
and they basically financed all my inventory. So,
Is that common or no?
from my understanding, it's not very common.
Okay. Must have been a
It's
great product.
Yeah, that you've got to find a manufacturer that likes your product. You have to, I had some big retailers interested in the product at that time, which that really helps
Yes.
give a boost.
Right.
So
Right. It's like a vote of confidence type thing, right?
yeah, absolutely, absolutely.
Right. Awesome. Well, that's great. And then down here we have MSRP and then margin. I assume if I change this to 50, all these numbers change. Yeah. So.
Yeah, exactly. So basically, it's just taking the production, the landed production cost, and then multiplying it by 4. It's kind of a rough idea, but typically your retail price needs to be roughly about 4 times, ideally about 4 times, anywhere between 2 and 4 times your landed production cost.
And but that's assuming this one here, right? So if we did,
Yeah, absolutely,
so if we
absolutely.
did equals 4 times this one, right? This would
Yeah.
be obviously a much more expensive product, but this is going to be one-offs, and this is kind of for people again with background in the K box, it probably is going to be lower quantity type thing. So
Absolutely, absolutely,
and
absolutely.
so yes, of course, if you get up into the 100,000, you start to get more margin. So these numbers though are basically only if you're at the high volume number, right? So since I did that lower volume, and like I said, the K box is kind of at that lower volume. You obviously would get more margin if you did get up there to the higher volumes, but we're probably not going to get there. And these colors are fixed, but it's probably the colors seem like they're fixed, but I've been changing the numbers around. So
Yeah, it's really difficult to make, you pretty much when you're, especially that first column is just 100 units. You're not going to make a profit on if you're doing manufacturing runs of 100. You'll be quite lucky if you can break even. Typically, when you're just selling your very early units, you're going to most likely have to sell them at a loss. You can't really price your product and be competitive if you price it based on you're running volumes of 100 when your competitors are running volumes of tens or hundreds of thousands.
right. So the
Um,
only time that would happen is if you don't have any competitors, right? Or if you're so
yeah, yeah,
extremely
which,
niche, like B2B type of setup, that would be the only
yeah,
time where you'd really actually be able to do that kind of thing.
yeah, absolutely.
Yeah.
And, I always like to say that, entrepreneurs think that they don't have any competition, but
Hmm.
there's always another solution. It may not
Sure.
be
Right.
identical or as good as yours, but there's always some competition.
Right. Yeah. The
Consumers
competition
always
might be
have an
some
alternative.
guy just wiring up his own setup, right? It might just be
Yeah,
not buying a
absolutely.
product at all. So
Yeah, absolutely. And
yeah.
that's a possible solution. So.
Yeah. Okay. Cool. Let's go back to the report here. So this is here. What's the next tab over? Development costs.
Yeah, development cost.
Okay.
So I kind of break this down into the electronics, the enclosure, and then programming.
Hmm.
So programming, you've got the design of the schematic, the printed circuit board layout. Of course, nothing is ever perfect on the very first version, which is kind of an eye opener for, a lot of people that don't have experience developing products. They think they can develop it and it's just going to be perfect and ready for market on the first version. And that just doesn't happen. It doesn't matter how good you are or what your experience level is.
Got it.
Um,
And so these product development costs, is this kind of referring to the for the development for the DfM product, or DfM being a, I guess I use that
yes,
as a verb,
yes.
but this is the redevelopment, I suppose, for a really solid manufacturable thing.
Yeah, absolutely. This is the cost to design a custom printed circuit board,
Right.
and get the firmware programmed, develop a mobile app. Most of the products I deal with have a software component, so there's typically a mobile app or PC software involved.
Right. Right. Well, and yeah, and we should also point out that these costs are also shown for people that are coming in with probably no experience, whereas people watching this probably have at least one or more of these skills in here, right? They might be good at PCBs, or they might be mobile developers, and they might be able to do 3D printing and development of the 3D models, or at least a prototype model. But then the rest is kind of hire out for everything else.
Absolutely. I always highly encourage, I think your chances of success are much better if you try to do and learn as much as possible yourself. It's not really that wise, I don't think, to be the founder of a hardware startup without understanding the product development.
I
So
agree
you
with that.
you need some piece of it. At least, there's a lot of people with software backgrounds, so you can, do some of the initial, firmware development, or, perhaps you can design the schematic, but you don't really know how to do a printed circuit board layout. So any of these steps that you can do yourself, you'll not only save money, you'll probably speed up your time to market, because no one is ever as motivated as the founder is
That's
to
right.
get their
Right.
product on the market. I went through that with my own product, which had a large mechanical engineering aspect,
Hmm.
and I was hiring, freelance engineers to develop it. And, me being the excited entrepreneur, I couldn't wait. They worked too slow for my taste. So I went off and taught myself 3D modeling and injection molding technology, and then just did everything myself, which saved money, saved me thousands of dollars, but also kind of sped everything up. So.
Right. Well, that can go pretty awry, but it sounds like it worked out.
Yeah,
Like,
it
it's not
can, and
always the
that's
right
why.
solution, but yeah, it does seem like it worked out for you with an engineering background as well.
Yeah,
So,
yeah, I wouldn't advise that if you weren't, if you had no technical experience. And
right.
and I still always, I always suggest that people get some independent review.
Right. Yes.
I'm a big believer in design reviews. When I designed microchips for TI,
Hmm.
any product I designed, I had to get up in front of a room of 30 engineers who wanted to try to point out every single mistake, that you had made,
Right.
which was great. There's a reason for that. And, no matter how careful you are, there's always people always, a fresh set of eyes always seems to find things that you've missed. So,
Totally agree with that.
so I do that for anything I design. I always typically will have another engineer review the circuit, just to make sure that I didn't look over something. So a lot of the makers I work with, I also do like monthly consulting with them.
Oh, great.
So if they're wanting to develop the product themselves, or maybe they want to hire someone overseas to develop the product at a much lower rate, there's a lot of risk associated with that. But if you're going to do that, then have someone that you trust that has the skills to review the work that's being done. So.
Right. Yeah, the sanity check that's worth a lot of money. That's worth a lot
It
of
really
time.
is.
Yeah.
It's one of the best things you can do, I think, to lower your risk and
Hmm.
increase the likelihood of that particular prototype version working as intended, is to get as many reviews as possible. So.
Yeah. Good. So there are a couple. So there's package development down here, but that's kind of what you're talking about. 3D model. Looks like this is for like injection molding, stuff like that.
Yeah, absolutely, absolutely. This is assuming that you have I mean, the 3D model, I guess, could be metal or plastic. Most of the things I deal with tend to have plastic enclosures. So,
Right.
you've got to have someone design the 3D model. Then, you have prototypes made of that. There's some other things in here, just like the instruction manual that goes with the product and things like that I include that are kind of minimal. They're not going to be
right. And again, it might be you developing it, but there's still cost to time and stuff like that.
Yeah, absolutely, exactly.
Great.
And when you know all these costs, then you can decide which of these, should I learn the thing that's only going to save me $500, or should I learn the skill that's going to save me thousands of dollars?
Right.
So.
Exactly. Especially if there's lots of iteration. Speaking of thousands of dollars, let's talk about the next tab over, because this one is the one that I think people think about usually way too late in the process, but can really is beneficial to think about early in the process, right?
Yeah, absolutely. Yeah, this one gets into the tens of thousands of dollars quite quickly. So, one of the biggest things that you can do to lower your certification costs is to use modules for any wireless functions. That's, in general, designing any wireless function, whether it be Bluetooth or Wi-Fi, is pretty risky. It's difficult to get them right the exact first time. Doing wireless design requires a lot of skills that I have found that most electrical engineers don't really have any experience with, mainly laying out the antenna and things like that.
Well, even having like the test equipment laying around for, being able to properly test this thing that you're not. Yeah, I totally agree on the module side of things. Yes, you're going to pay more per module. And Thomas is using, on the K-Box, he's using an ESP module, which has its own issues because it's, source only from China, and it's a little bit harder to get in the supply chain, but it is certified, and for that perspective, it actually is valuable.
Yeah, and I personally love the ESP modules. I mean, their pricing is just,
it's just changing things. For sure. I think
it's like crazy. I mean, another module, maybe $10, and their module is only $2. It's really difficult if you want Wi-Fi or Bluetooth. Then it's
right, especially with the ESP32 coming out.
That one I really like with the Bluetooth, and it's cheaper than just a Bluetooth low energy module by itself, and it also has Wi-Fi and the standard Bluetooth. So
say someone put an ESP32 on a board, what would they have to actually do of this list of certifications then?
In that case, you would have to do the FCC certification. Every product is going to require that. The big difference in the two types of FCC certification is a non-intentional radiator and an intentional radiator.
Okay.
So an intentional radiator is a product that intentionally radiates electromagnetic energy as radio waves. A non-intentional is a product that doesn't intentionally radiate electromagnetic waves.
Does it by accident.
It just by accident, exactly.
Yeah.
So if your product has a wireless function, then the smart way to go is to use a pre-certified module, so that your product will be classified as a non-intentional radiator.
Okay.
Which is, you're talking about probably 10 times less for the FCC certification cost. You're, talking a couple $1,000s versus tens of thousands.
Got it.
So that's a big one that you can, just using an ESP or any wireless module. If you use that for all your wireless functions, then that will save you, a minimum of $10,000 on your FCC certification.
Wow. Okay. Right. And then there's also the whole, if you were going through that, say you were taking on that task, the whole idea of you should be thinking about the best case guidelines at the beginning, right? So you should be thinking about, how your antenna is made, making sure your impedances are matched, all that kind of stuff. Are there any other quick tips on making sure you pass that non-intentional? I mean, is that something that people normally fail or no?
I've had, if you're under non-intentional, there may be a few changes that you have to do, but typically I find it being a little more problematic with the intentional radiators.
Got it. Okay, that's good to know. Right, and someone like you could, there are consultants that take people through the FCC certification process as well that have done it many times and can kind of do a design review, do that kind of thing. That is.
Yeah, and it's very detailed. It's not really something I do a whole lot. I don't really typically hold your hand through FCC certification. I've worked with it a lot, but it's not something that it's good to have an engineer that can help you along with that, but it's not really something that I've done a lot.
Finding a specific engineer for that kind of thing.
Yeah, exactly.
Okay. What about UL and CE and RoHS? I mean, so these are all country specific, but when do people need to do them? Maybe that's a good question.
Well, the UL certification is, so let's just assume the US for now, the UL or CSA, which is, they're both interchangeable between the US and Canada. UL certification is required if your product plugs into an electrical outlet. So if you're, if you're taking, the 110 AC and converting it down to 5 volts inside your product, then you have to have UL certification. Most products I design don't do that because instead of, building their own AC DC converter, they just use a USB charger. So in that case, if you're using a USB charger, that the UL certification falls on the charger, which you're, most likely using. You're not going to design your own. You're just going to use one that's already developed, that's already been UL certified.
So does this also go for like offline switchers, like wall power AC to like a 12-volt power supply? That just has to be certified
that
separately?
would require the UL certification.
Oh, even if you bought a UL certified power supply, you still need to get.
Oh no, I'm sorry. Not if you bought. Yeah, I thought you meant if you designed that power supply.
God. No. I meant like buy a finished module type thing.
Yeah, absolutely. Then you can bypass that.
So it seems like all these, so certifications in general, just to kind of, so we can move on to the next thing, is certifications in general. If you buy a module, you're going to pay more per, but if you kind of carry the certification with it. That seems like the general rule.
Yeah, absolutely. And in general, it's when you're starting out and, if you don't have a huge budget, it's always best to focus on minimizing your risk, not maximizing your profit in the beginning. Worry about, don't worry about profit later, but worry about maximizing and squeezing every penny out of your profit down the road. It's like, don't.
Iteration 2, iteration 3, right? When you're already into manufacturing, you've gone through
don't spend tens of thousands of dollars on certification if you can bypass that, and it's just going to add a little extra cost to your product. You can go back later, get rid of modules, and replace them with custom circuits once you've proven the profit.
Pay for that with profit, hopefully, right?
Yeah, exactly. Yeah, exactly. So, yeah.
So what is this last tab? Well, there's a couple more tabs here, but you said we don't need to really look at scaling costs. This is just setup costs?
Yeah, can we go back to the certifications? Just one more comment real quick about the UL certification.
Yeah.
The one case where you will need UL certification, regardless if your product plugs into an electrical outlet, is if you go to sell it to any large retailers. If you're going to sell your product to Walmart, they don't really care if it is a USB charger or plugs into the wall. They just want to cover themselves, and they're going to require UL certification.
Got it.
So it's another reason to start off selling the product on your own website. Then that way you wouldn't have to have the UL certification.
Right. And it is more about, so it sounds like it's about the customer. If the customer is asking for it, you definitely need it. There are some baseline safety things you should be doing, but those are these are like marks of confidence for consumers or retailers or whoever's buying your product.
Absolutely.
Okay, great. So setup costs here. This is, let's see. So we got molds and you price it out for different.
We have molds, and molds. That's
right. This
that's
is the moldy.
Pretty
page.
much the dominant thing when it comes to setting up manufacturing. A lot of people tend to think, the electronics is, usually can be the most complicated part to develop, but it tends to be the easier part of your product to scale to manufacturing.
Right.
It's because the exact same process is used to prototype the electronics or prototype a custom printed circuit board is used to manufacture them. That's not the case with the plastic enclosure. You'll use 3D printing most likely for prototypes, but once you start, needing more than just a few units, you're going to have to switch to injection molding. And injection molding, especially for high volume molds, is, tens of thousands of dollars. I mean, they can easily get up to $100,000 if you have one that's, got, 16 cavities in it, so it can produce 16 parts at one time, and is, made out of an incredibly hard steel that's good for, 1 million units. Then you can really get up into high cost on the molds. So that's why I break it down into, typically you're not going to start with molds made for producing 1 million units. I mean that would be really crazy. You're going to start with aluminum molds most likely.
Right. Right. And the trade-off I actually did not understand when I was getting started in this thing is that the hardness or softness of the mold, it also relates to basically how long it takes to make the mold. Right. You're actually having someone milling out a block of metal. and
Yeah, absolutely.
it's it's matching your 3D design models, but then there's always the contours and all the drafts and whatever. But basically, it's directly tied to the material cost of that block of metal, and then how long it takes to design it, that the design files for the mold, and then actually milling it out and finishing it, yada yada yada.
Absolutely, absolutely. I mean, yeah, a mold made out of a really hard steel can, from my experience, can take 3 to 4 months for them to make.
Oh
It's
wow.
yeah,
Right.
yeah, it's really complicated. It takes a lot of labor, and a lot of time to
Yeah.
to machine things out of
Right.
a really hard steel.
Right, and that is a entire other field, and I do hope to have a mold expert on the DfM case study at some point. But yeah, that's kind of like one of those things where it's like until you're, people think about their consumer level electronics, right, with like these super smooth finishes too. That's one of the most, the smooth finishes are super tough to do. You have to, and then like you said, getting tons and tons of shots out of each mold.
Yeah, absolutely.
It just increases complexity and especially cost.
Yeah, it's really I find is one of the more underestimated steps in bringing a product to market is people just don't realize that you're talking big money to take it from prototype to setting up manufacturing, and unfortunately that's mostly due to molds. One of these days I think 3D printing will be efficient enough to be used in mass manufacturing, hopefully.
Maybe. Well, we
That's
can argue
not
about that afterwards, but yeah.
yeah, that's not the case right now. But yeah, so it's something that learn as much as you can about injection molding because
Sure.
it's going to be really important later on. And my main advice is make sure if whoever does the 3D model for your product, make sure they understand injection molding. You can 3D print anything, and there are very strict rules when it comes to what can be injection molded.
Right, with overhangs and
Yeah, undercuts and side actions, and every wall has to have a slight angle to it, and
right. And thickness of the walls itself too.
thickness of the walls. If you do the walls too thin, then the plastic doesn't flow smoothly and evenly through the mold. So there's simulations that you can run on that. So it gets to be pretty complicated. So
Definitely. So to take it back to the the K-box is actually using a project box. How much of the time are your clients actually using project boxes versus 3D printing versus other methods?
I would say maybe 25% probably use like a stock project box. That's another area that I highly encourage people to do. Another thing that I encourage them to do to save money is to try to find some type of enclosure that's already available that you can use with your product, at least initially, mainly because you're going to save all these costs for the mold costs.
Right. I can imagine people being like, well, I want it to look this certain way, and it's like, yeah, you'll get there. Like that's kind of the hope, but at least prove it out in the marketplace first with a project box. Make sure the guts work and that people actually want the guts of the product before they're caring about fit and finish and all that other stuff.
Absolutely. It really, especially with hardware, it's all about the minimum viable product concept. I mean, you think you may know what your consumers or customers want, but you really don't. And the only way to know is to get something out there and begin getting feedback from that.
Awesome. So a couple of the tabs here, you got scaling cost. Like we said, that's probably off a little bit later in the future for most people getting started. Engineering review, these are kind of like, this is what you'll do for, design type review, or what is it?
Yeah, this is basically me, selecting all the components, the Bluetooth module, the, sensors, and this is basically just a written description of, why I selected these modules and just suggestions on how to, improve your product or how to lower the risk or lower the development costs and such.
Got it. And then a cost savings, this is basically you saying, okay, you've got this product, you've got these processes that you think you want to be doing, how can we reduce costs and actually lower your overall cost to market?
Absolutely, which, we've kind of touched on some of those, use wireless modules, use a project box instead of a custom enclosure, those types of things.
Awesome. So any last advice for people that are thinking about getting into this? Maybe they are interested in a hardware report, or maybe they're just, on the verge of taking a thing to market. What do you usually talk about when you first talk to a new hardware maker or someone taking it to production?
Yeah, my main thing I tell them is don't, I know how excited entrepreneurs can be, and they tend to want to just jump headfirst into, spending lots of money developing their product. And I highly encourage you to not. Developing a new hardware product is incredibly risky, and you need to be smart and methodical about the way you bring the product to market. So basically, learn as much as you can, and that's one of the main reasons I came up with the report. Is not only does it give all these estimates for pricing, but it really teaches you a lot, and it shows you that there's a lot to developing a new product. I mean, it's not something you're going to do for a couple $1,000s. There's a lot to it, and it's going to take you. You're going to be spending years. Through the whole process. I mean, getting it manufacturing set up and getting customers, and there's just a lot of obstacles in the way, and the only way to surpass those obstacles are to know about them before you get to them.
Right. A solid dose of reality will actually do you good.
Absolutely,
it's better,
absolutely.
Better than ignoring it and realizing it much later, right?
Yeah, and some, I'm sure I get some, clients that, I do this report for, and they're like, oh my gosh, I had no idea there was this much involved. Forget about it. I'm not gonna. This is too much for me. But I still consider that a success, because the worst case is, I hate seeing people like blow through their life savings,
right,
and not really have any realistic expectations of the process and the steps and the obstacles that are ahead.
Mm-hmm. Well, that's great. No, and I think that, like I said, sanity checks for mid-design or pre-design, all those things are very useful. And even people that are thinking about crowdfunding, right? They're setting certain goals based on, I think it will cost this much, but taking an honest look at all the total costs, including development, everything else, that can be really useful when you are trying to either raise money or use your own money. So that's good.
Yeah, absolutely. And that's one of the things the report is good for, is if you're trying to raise money, if you're going to raise money, first of all, you have to know how much money you need. Mm-hmm. So that's, that mainly comes down to the development and the scaling cost. And then, you need to know how much inventory is going to cost. And the only way to know that is to know how much the product's going to cost to manufacture. So.
Got it. Awesome. Well, where can people find your stuff online?
Predictabledesigns.com.
Okay, awesome. Yeah, there's lots of great articles there too. Not just the reports, there's also lots of great articles that John writes. So thank you, John, for being on, and we look forward to having more DfM stuff in the future.
Okay, it was great talking to you, Chris.
All right.
Okay, bye.